So this is a continuation of what we were discussing. We have to deduce a general for, and they mention here compound X and Y, they have the same general formula. X and Y both are carboxylic acid. So we have to draw a structure of carboxylic acid which is having a 4 carbon. Because in the next part, they ask draw the structure of a compound Y. Compound Y contains 4 carbon and it is a carboxylic acid. So for 4 carbon, it should be bute because of 4 carbon bute, and oic acid because of carboxylic acid. So we have to draw butanoic acid. So bute means 4 carbon. So first we'll draw 4 carbon, 1, 2, 3, and 4. Then the carboxylic acid, the functional group is always with the first carbon. So C double bonded with O and H. And we have to show all the atoms in the bond. So you cannot write like this. If you write OH, that is wrong. Why? Because we have to show all the bonds. So there is also a bond between oxygen and hydrogen. And there's a single bond between the carbon atoms. And each carbon maximum can form 4 bonds. If one is with other carbon, so this will have 3 hydrogens. This will have 2 hydrogen. This will have 2 hydrogen. And what is the name of this compound? Because 4 carbon atoms are there, so it will be bute because of 4 carbon, single bond N, and due to the functional group, it is oic acid. So it is butanoic acid. Then give the name used to describe the family of a similar compound. So which are having a similar chemical properties, so we call them as homologous series. So homologous series is a name given to a family of a compound which are having a same chemical properties and a functional group, like alkane. All alkanes are homologous. See, it's one of the homologous series. All alkenes homologous. Alcohols homologous because they all have the general formula as well as similar chemical properties. Propene, which is an alkene, is unsaturated hydrocarbon. The formula for propene is shown. State the color change which we observe in aqueous bromine. Whenever we add aqueous bromine is orange in color. But when it reacts, it will decolorize, so it will become colorless. So whenever alkene plus bromine water or aqueous bromine, it will always from orange to colorless. Propene can be produced by cracking a long chain alkane. Pentadecane, which is C15 and H32, is cracked to produce alkene in the ratio of 1:2, alkene and a propene with a ratio of 1:2. Like it produced 2 moles of propene and remaining alkane. We have to complete the equation. So if it produced 2 propene and 1 alkane, so 1 propene, prop means 3 carbons, so C3 and H6 should be there. And the ratio between them is 1:2. Like if it produced 1 alkane and it produced 2 propene molecules. So it will be C3, H6, and how many molecules are produced? 2. So how many alkane, what will be the formula of alkane here? So we just have to make a number of carbon same here. On the left hand side, we have 15. On the right hand side, 2 multiplied by 3, 6. So how many we are left with? Out of 15, 6 are used here. So we are left with 9. And hydrogen, 6 multiplied by 2, 12. So out of 32, if 12 are used here, so remaining will be 20. So C9H20 and the 2 molecules of propene will be there. Then propene can be converted into polypropene. Whenever alkene converted into polyalkene, what we call this type of polymerization, we call that as addition. Alkene always addition. Nylon, polyester, protein, fats, carbohydrates, that is condensation. Complete the diagram to show a section of a polypropene. Look, say this was a propene. This was a propene. The structure of a propene was given in the beginning of the question, which was here CH3, CH, and CH2. So this was CH3. Color is brown for bromine. Bromine liquid is brown. Like if I have a pure bromine, if I have only bromine in a liquid state, that is brown in color. But when I have aqueous bromine, like bromine mixed with water, it is orange in color. So there is a small difference in the color of an aqueous bromine and a liquid bromine. So it is CH3, CH and double bond CH2. Whenever we draw a polymer, remember first we have to rearrange the structure of a monomer. Our monomer should appear like letter H. So it will be C double bonded with C, 2 bonds up, 2 bonds down. So these are the 2 carbon which are having a double bond. Right hand side carbon is having 2 hydrogens. So 1 hydrogen up, 1 hydrogen down. And then it will have left hand side carbon having 1 hydrogen and then CH3. You can make up or down, it does not make difference. So this is also a monomer. To draw a polymer, what we will do? We will draw the same structure but without a double bond. So this is one monomer. Then there will be another. And we link them together, put a bracket and N. So we have to just complete here the same thing. So this will be H here, H here, H here, and then CH3. This is one molecule. And then other molecule H here, H here, H here, and CH3. And these are the 2 molecules linked with each other to form a condensation, to form an addition polymer. So this was the last question from May-June 2021 paper.